Alright, this is true object detection. This is what's known as surf tracking. And surf stands for like sped up, robust features. Cool, I remembered. Anyways, I want to show you first off what this program does. Here's me. Here's my little checkerboard design. Now, the cool part about this is I can put anything up here and it'll track it. Semi-okay. So anyways, I got a button here and I can hit set. Aw, snap. Look at that. That is the other side of my program here. The blue is the tracked feature. This is the matched image and it's matching points. That's actually tracking really nicely compared to what it was before. But yeah, even does some kind of rotation. Now mind you, my webcam is not the greatest, neither is my computer. But yeah, see how that area keeps going a little nuts? Actually, a nicely trained feature will actually track the perspective of it too. See how I've leaned it back and it's kind of tracked that really nicely? See if I can lean it forward. Yeah, it's tracked that nicely too. Ain't that neat? True image detection. From whatever I set it, that's what it'll track. Now, that's super stinking cool and I love it. I don't know if I'm excited about it because I finally figured this whole thing out or because I'm hopped up on caffeine. But anyways, this program is pretty stinking large. It is 95 lines, so I guess not terribly large. But it, I know it contains characters that YouTube will not allow in the description where I usually stick all my code. So what you're kind of going to have to do is use the full screen and kind of copy the code down if you want this code, because this is the only Visual Basic code that I have found to work with this stuff. Everything else I found using this is all in C#, and I had to convert it all over. So this is the Visual Basic version of surf object detection. Now I'm going to go through what it's doing real quick. I have two big picture boxes here and a single button that's called set. So the first thing I do is I pull in my Emgu.CV stuff, and that is from the Emgu.CV SDK or API or whatever the heck you want to call it. It's stuff you got to import to make it work. I'll link a video showing how to do that easily. Now, next I've defined a couple things: a capture for the webcam, a setz Boolean, true or false, basically, and that sets is my image set or not. Saved image as my little 150 pixel wide and high image that I actually am tracking for. The image that I will pull the graphic result from, and the result image, which is the whole blue box with lines and crap on it. So anyhow, on that little button click, this guy up here, that little button click, I will have the saved image equaling a frame that is a center of 75 by 75 or 150 150, and then I set the sets as true. So now I also have a timer on here, forgot to mention that, interval of 10 and enabled of true. So on this timer tick, I have the image 1 pulling a gray frame and setting that gray frame as image 1. And then if set is true, basically I've set my image, then it does all this stuff down to here. Now, skipping all that stuff, at the bottom here, I'm defining a rectangle as starting at 0, 0 and ending at 150, 50. That's that white box you see. And I draw that white box, here's the white portion of it, the gray 255, a width of 2, and drawing it to the image 1, and then displaying image 1 to the first picture box, the one on the left. And that stays constant all the time. Now, with the saved image set, here's where it gets crazy. First, I gotta define a couple things, and I don't really honestly know where to begin with this because this is just a big mess. But I gotta define a surf detector, a homography matrix, a couple of vector key points, and 3 different matrices. And then pulling the points from the saved image, which is my little image, and putting those into descriptors. And descriptor is like, if I were to define what surf is doing, it takes like this small chunk of pixels and looks at the direction in which the pixels are flowing. I know that sounds weird, but look up surf on Wikipedia, or surf vision, if you will, or vision detection. Surf, it's spelled just like, waves, S-U-R-F. And it'll show you that that's the way it works. So the pixels are flowing in a certain direction, and this has a size of the pixel, a direction the pixels are flowing, and then like 64 or 128 bytes of, not bytes actually, but decimals of just a description of each of these points. And that's the points you see when it's matching an image here. So just take a random pick and see each of these dots that's describing here. Each of these is a point, and that is its center, and that matches right to the center of one of these points over here, because this is a certain point that has something specific and unique about it, and that's why it knows to track that specific point. And then it uses these points together from both the saved image and the image I'm currently pulling from to match. This is the next part, the matcher, or brute force matcher, whatever that means, and combines the two. Now down here there's a couple more things. Like a vote for uniqueness. This determines like a uniqueness threshold, and then there's some other stuff as in size and orientation, and this would kind of be where you define your scale and rotation, how much you wanted to scale and rotate. And then finally get the homography. And homography is like, how much does this look like this in computer terms? And so once we've gotten our homography, which is the key thing here, I want to go result image. I'm going to draw the matches. Those little lines with circles on them. And that'll take the saved image, stick that in the upper right, and its model key points. Take the big image I'm pulling from, which is the left side of the image and its points, and put the two together with a white lines and white circles. And this just tells it how to draw it. Now finally, the blue box that I have defining where my whole image is, that is defined by a rectangle of 150 by 150, and he wants to see some I guess data in this before it actually will use it. So the example that I used, the C# that I converted into Visual Basic, used the rectangle of 150 of 150 of 150, left, right, top, and bottom. And then I take those, and because those are in PointF structure, I take those and put them into points. And so therefore the homography can put the project points into the structure of an array of PointF types. Now once I have those set, those go into an array of standard drawing.point type, an array of that. And that's what the rectangle image draw polyline is drawing, is this array of 4 points, true for closed, the color, and then the thickness. And I do have a try around this whole section here, and that's because homography, if it doesn't find any matches at all, it'll actually throw fault and stop your program. So I might as well just throw a try, catch the exception, and then just throw it away and end the try. And then finally, result image goes into the picture box 3. I had a second picture box in here, it's gone now, so this guy's picture box 3. That's the one on the right. So anyways, that is that.